Hi everyone. Today we're gonna go over the Puritan Bennett ventilator made by Covidian, and we're gonna learn about the gas flow behind it. And the PB980 ventilator, for short, is fundamentally a gas delivery system. While the user interface shows pressures, volumes, and waveforms, underneath all of that is a very carefully controlled pathway that moves medical gases from the wall to the patient. Understanding how gases flow through the PB980 is very essential for engineers. Many faults, alarms, and performance issues only make sense once you understand the intended gas pathway and how the system regulates it. With this presentation, it explains how the PB980 gas flow from an engineering perspective. We are not focusing on clinical settings or modes. Instead, we are looking at how oxygen and air enter the ventilator, how they are blended and controlled, how they are delivered to the patient, and how exhaled gases are measured and removed. The PB980 receives gas from two primary sources: medical air and medical oxygen. These gases are supplied from the hospital pipeline or perhaps cylinders and enter the ventilator through dedicated inlets. Each gas source is continuously monitored for pressure and availability. If supply pressure falls outside acceptable limits, the ventilator will generate alarms to protect patient safety. From an engineering perspective, many ventilation issues originate upstream of the ventilator. Understanding the condition of the gas supply is the first step in diagnosing flow-related problems. Blocked filters, low wall pressure, or even incorrect hose connections can all affect downstream performance. The ventilator assumes that supplied gases meet medical standards, and it is the job of the engineers to verify the integrity of the supply before investigating internal faults. Once gases enter the PB980, they pass through internal regulators and proportional valves. These components reduce and stabilize incoming pressure to levels suitable for precise control. Proportional valves are electronically controlled to adjust gas flow in real time. This allows the ventilator to deliver the exact volumes and pressures required by the selected ventilation mode. From an engineering perspective, these valves are critical components. Contamination, wear, or calibration drift can affect flow accuracy. Understanding their role helps engineers interpret alarms related to volume delivery, pressure limits, and flow errors. The PB980 continuously monitors valve performance to ensure commanded flow matches actual delivery. The PB980 blends oxygen and air internally to achieve the desired fraction of inspired oxygen, FiO2. This blending occurs before gas is delivered to the patient. The system calculates how much of each gas is required and adjusts proportional valves accordingly. Sensors downstream verify that the delivered mixture matches the commanded FiO2. For engineers, blending issues can present as FiO2 alarms or inconsistent readings. These faults may relate to sensor accuracy, valve performance, or upstream gas supply problems. Understanding where blending occurs in the flow path helps isolate whether an FiO2 issue is mechanical, electronic, or supply related. Once blended, gas enters the inspiratory flow path. It travels through flow sensors and pressure transducers before reaching the patient circuit. Flow sensors measure delivered volume and flow rate in real time. Pressure sensors ensure that airway pressure remains within safe limits. These measurements feed back into the control system, allowing continuous adjustment of valve positions. This closed-loop control is what allows the PB980 to adapt to changing patient conditions. Engineers troubleshooting delivery issues must consider both the physical flow path and the sensor feedback that governs it. The patient circuit is external to the ventilator, but is a critical part of the gas flow system. Tubing, filters, and humidification devices introduces resistance and compliance that affect delivered flow. The PB980 accounts for these factors during ventilation, but excessive resistance or blockages can still cause alarms or reduce performance. Engineers must remember that not all flow issues originate inside the ventilator. Kinks, water accumulation, or incorrect circuit setup can all disrupt gas delivery. A clear understanding of how the external circuit interacts with internal flow control is essential for effective troubleshooting. During exhalation, gas leaves the patient and returns through the circuit to the ventilator. The exhalation valve controls how this gas exits, maintaining appropriate pressure and timing. Exhaled gas passes through sensors that measure exhaled volume and flow. These measurements are used to calculate parameters such as tidal volume and minute ventilation. Exhalation valve faults can cause pressure instability, rebreathing, or alarms. Engineers must understand this pathway to diagnose issues related to high pressure, low volume, or inconsistent measurement. Sensors are central to PB980 operation. Flow and pressure sensors provide continuous feedback to the control system, allowing real-time adjustment of gas delivery. If sensor data is inconsistent or missing, the ventilator cannot reliably control flow. In these cases, protective alarms are triggered to maintain patient safety. Engineers must distinguish between true flow problems and sensor-related issues. Calibration, contamination, or sensor failure can all present as flow abnormalities. Understanding the feedback loop helps engineers avoid unnecessary component replacement and focus on root causes. Many common PB980 alarms relate directly to gas flow. High pressure alarms may indicate obstruction or excessive resistance. Low volume alarms may suggest leaks or insufficient supply. These alarms are not diagnoses. They are indicators that actual flow differs from expected behavior. Engineers who understand the full gas pathway can interpret these alarms correctly. Rather than reacting to the alarm alone, they trace the flow path logically from source to patient and back again. This approach reduces downtime and improves patient safety. The PB980 ventilator is, at its core, a system designed to move gas safely and precisely. Every alarm, waveform, and parameter is tied back to how gas flows through the system. Engineers who understand this flow path are better equipped to support the ventilator effectively. They troubleshoot logically, communicate clearly with clinical staff, and make decisions that protect patient. In ventilation, understanding gas flow is understanding the device itself. That knowledge turns alarms into information and support into confidence.